In this video, I want to do some examples of adding rational functions without a common denominator. In step one, as I was saying in the last video, is to find the LCD first. Then once we find the LCD, we need to rewrite each denominator as the same by matching up with the LCD using the factors that we're missing between the pair. Then once the denominators are matching, we can do exactly what we did 2 videos ago, where we can, once we have a matching denominator, we can add or subtract across the top, and at the end, again, simplify if at all possible. So let's start off with the first example, 1 over 3x squared plus 7 over 18x. So here I want to first find the LCD, but it would be 18x squared, because if I take the first one and I multiply by 6, that would give me 18, and the other one is already 18. And if I take the second one times x, that would make 18x squared. That would be the same. So sometimes you might be able to figure out the LCD without doing what I did before, but I wanted to explain the process for those of you who have a little bit of trouble with identifying the LCD in each of these cases. But there's usually some shortcuts and some, you don't have to do the elaborate process I was explaining every time. And of course, because of how fractions work, when we multiply into the denominator to match up those denominators, we need to make sure we do the same thing to the numerator as well, because we want to make sure to keep each fraction equivalent. We don't want to change our expressions, we just want to add them together. And we're always allowed to take a fraction and multiply by a common factor, because it will cancel out anyways. But we're kind of unsimplifying these expressions so that they have a common denominator. And now what we'd be left with is 6 over 18x squared plus 7x over 18x squared. And right here, you don't want to simplify because that was the whole point. Because now that I have a common factor, what will happen is it will add across the top and the denominator will stay the same. So, well, 6 plus 7x, those cannot be added because they're not like terms. So in this case, we can't simplify our answer because 7x plus 6 has no common factors. There's no way to reduce it. And remember, we can't reduce the 6 over 18 because this is that you can only cancel when it is factored. It will not cancel when there is addition within your rational expression. So looking at another one, like in the case if you were trying to take a rational function and add it to a non-rational function, remember that anytime we have a non-fraction, you can always write it as a fraction by putting a 1 under it, because any whole number could be expressed in fractional form, because dividing by 1 doesn't do anything and is equivalent. And once I do that, I could figure out, well, the LCD between x plus 2 and 1 is just x plus 2. So in this case, I would want to multiply the second fraction by x plus 2 on top and bottom, again, because I always have to do both top and bottom in order to match them up. And so the first one I can actually leave alone, and the second one would leave me. Now, when you're trying to add, I would always recommend multiplying out the numerator, because that would distribute to be 2x plus 4, because I'm going to eventually need to add them together, and it won't help me to have it in factored form most of the time. And of course, the denominator is matching. That was the point. So again, first step, match up the denominators however you can, but easiest way is by using the LCD. Now I add across the top, and the denominator stays the same. So the denominator x plus 2 remains x plus 2. And the top would give me 2x is not going to combine with anything, and 3 plus 4 is plus 7. And again, this will not reduce because there are no common factors in there. Now, looking at the third example, the denominators here are totally different. And it's sort of like in this example where I had a denominator 7 to 4. Sometimes you have no common factors between the two denominators. And in those cases, it's actually almost easier because you can just multiply the two denominators together in order to match them up. So in this case, the LCD will just be the product of the two denominators since they share nothing. And remember, 2x and x plus 2, even though they look very similar, they don't have common factors because neither one, they're both in simplest form. And I would need to make sure to take the numerator here and multiply by x plus 2, and the numerator here multiply by 2x. And remember to FOIL whenever you need to, because the numerators I always want to multiply out. Because the numerator, well, x plus 2 times x minus 4, that would leave me with x squared minus 2x minus 8. The denominator you can actually leave factored though if you want, because it's going to be the same at any rate. But I'll go ahead and multiply it out. Usually I'd suggest not multiplying it out, because it usually will just create more work for yourself. And then in the right, the second rational function, we have 8x squared over same denominator. And I'll just rewrite it in the same order to emphasize that it is the same. And I don't really need parentheses around the 2x here since it is a single term, but whatever. And now that I have a common denominator, I can go ahead and combine like terms. X squared plus 8x squared would be 9x squared, and then the other two will remain consistent because there is no other like terms. And this would leave me with my answer. And again, last thing I want to check is there a common factor? So in order to look at this one, I would need to think, well, can the numerator be factored in any form? So I would need a magic x to check to see if the numerator is prime or not. A lot of the time it will be prime, but as usual, we won't know until we check. Like 72 is 8 times 9. That's not going to work. It's also 4 times 18. I believe this one is prime. Oops. Yeah, that makes sense. 4 times 18. It would also be 3 times 24. It should be 6 times 12. But if I'm looking at all these combinations, I needed one positive, one negative. None of those add up to -2, and I'm pretty positive that this is going to be prime. So anyways, this one will not reduce, but it's something you always want to consider because it may or may not cancel after all is said and done. I'd say normally they will not simplify, but it's always possible.